Everyone, this is the fourth note, the third video. Previously we talked about the budget constraint, and then we talked about indifference curve and utility function. Then with these three tools, we'll be able to analyze what's the optimal consumption that a consumer is going to choose under the budget constraint, as well as the prevailing price of the goods in the market. And basically, you've already learned about this material, but therefore I want to focus on the intuition. So basically, like graphically, what you see is that the black line is the budget constraint, the blue line is the indifference curve. The higher the indifference curve, the higher the utility level. Therefore, the consumer wants to go as high as possible, but still keep the consumption within the budget set, and actually within to be more precise, is to within the budget line, this black line. And as you move outward, and ultimately you're left, you're about to leave the budget set region, and then just at that point, that one last tangent point, you stop there. That's the point where a consumer is going to exhaust all the budget, and then but also at the same time achieve the highest utility level possible. And at that point, the budget line overlaps with the tangent line of this middle blue indifference curve. And because of the low overlap, we know that the budget line's slope is given by negative P1 over P2. The slope of the tangent line, which overlaps with the budget line, is given by negative mu1 over mu2, which is the MRS. Therefore, we have the equation that negative P1 over P2 is equal to negative mu1 over mu2, and we cancel the negative sign. What we get is the P1 over P2 is equal to mu1 over mu2. Okay, so this is the first equation that we're going to use to solve, or the first relationship that we're going to use to solve for the optimal bundle, consumption bundle. And the second equation we're going to use is the budget line. So it's the budget equation. So the money you spend on good 1 plus the money you spend on good 2 is equal to your income. Okay, so I think it's easiest to learn about this stuff by going over examples. So that's what we're going to do. So the first example we're going to see is we're going to solve the optimal consumption bundle in a Cobb-Douglas utility function. This utility function we solved once in the last note, and then here we may have a slightly different notation system working, but it really doesn't matter because x1 really just stands for the units of consumption in good 1, x2 is the units of consumption in good 2, c and d are exponents and they're constant. Okay, so first, we want to log transform our Cobb-Douglas utility function, because if we log transform it, to solve for MRS is so much easier. Okay, so we take a log on the left-hand side. On the right-hand side, the log of this product becomes c times ln x1 plus d times ln x2. Okay, our goal here is to maximize the utility, okay, given by the Cobb-Douglas form, but abiding by the budget constraint. This is just a mathematical way of saying how to get to this point. You are constrained by this budget, and then you want to move as forward as possible to get on the highest indifference curve you can get on, but still within the constraint. This is just the mathematical language of saying that. We already know that this maximizing process lead to this relationship. I hope the background noise is not too much. I'm making this video in the Lehman Library study area, and it's not the quiet place, as you know. But I hope it's okay. So this relationship, MR1 is equal to P1 over P2, is actually already a result of this maximization. And this second equation is just the budget constraint. These two equations give us a system of two equations and two unknowns. The unknown is the x1, x2, and the constant are c, d, p1, p2, and m. Remember that p1, p2, and m, c, and d are constant, they're given. The only variables whose value we don't know is x1 and x2, and we're solving for them. And then the rest is just about solving this system of two equations and two unknowns, and we'll be able to solve for the optimal consumption bundle. So the optimal consumption bundle, the consumption of good one, is given by this form. All of these letters here are constant, they're given, and x2 is given by this form. And I will actually give you a second way to solve this maximization problem, but in hindsight, I think you should ignore that for now. Just focus on how we solve for the optimal consumption bundle in the Cobb-Douglas case. Please feel free to email me if you have any questions. I feel like the disadvantage of giving you this video is that I can only give you the overview. I can't really do the math with you step by step, which is actually quite important. So if you can't finish the math yourself, please don't fret over that. You can always come to me during this after the semester starts, because I will be your micro tutor and I will walk you through each of the steps. This process, this math that's shown here is actually very important, because you'll be using that again and again in this coming semester.